Good afternoon, ladies and gentlemen. Welcome to Algebra 2 Honors. Today we're going to be looking at this exercise set 12 through 16, which is continuing on from number 11, which was a similar problem to number 12. Your printing is probably better resolved than mine up here, so it looks fuzzy up here. That's because of the limited resolution from the copying. But my grid may be more available than yours, which didn't come out as well in the copying, so you can see where it is. So you have this situation where you're trying to graph unemployment rate versus time. And fortunately or unfortunately, this happens to be a time when all of you were living from 2003, you're little kids and babies, so very young, right? So you're born, almost born, right? So very young. So we're going to start with 2003. I guess that is before most of you were born, right? But just a little bit before you were born. So, in 2003, the unemployment rate was at 6.3%. So how would we graph that particular point of data on the graph? So 0, and then 6.3. So 0, right? 6.3. So where does that go? About right here?
Yeah.
Roughly here. Okay, one thing I started to do in the other classes that I thought was helpful for this exercise is this thing right here. That if you go ahead and make a, what do we call this thing? Make a chart or a table, right?
Yeah.
Is that you can, it might be easier to avoid mistakes doing it that way. Do you have to do it that way? No, you don't have to do it. But what happens that over time I become conditioned to kind of look for things that will make my life easier. Why do I want to make my life easier? Because it's easier, and what else? In what other respect will it make my life easier?
Saves time.
Saves time. And one more thing. I know I'm fishing for an answer here. Avoiding mistakes, right? And so sometimes to go from text right to here, it might be easier to have an intermediate step. Actually, it might save time, but it could be more work, could be more time, right? But in this case, we have these numbers, and we're sort of, we look at them, we say, okay, well, that's our first year. That's easy, because that's at 2003. And then begin to fall over the years and reached a minimum of about 4.4% in 2007. So on this chart, where does 2007, what corresponds with 2007 here? And how do you get 4?
You do 2007 minus 2003.
2007 minus 2003. And then we went to 4.4, right? So now, by 2007, you have done what in your own lives? You have come to life yourself, right? So now you are all alive, right? And you're proceeding 4.4 unemployment rate. And then a recession began in 2007 and caused the unemployment rate to increase over a 2-year period. So what would we do for, what would a 2-year period mean here? So you put 6, right? So if we just add, And see, to me, setting the table is pretty good because you can just see, okay, 2 more years, add 2 to 4, and then we reach a maximum of 10%, which happens to be, I think, almost the current unemployment rate
It's like 3.
with the pandemic. Pardon me?
Oh, with the pandemic maybe, but
Yeah, but it was at 3% or a little over 3% for a long time. But anyway, so we had a recession here, and then, so there we are. It's in 2009, and then the unemployment rate then decreased over the next 4 years, and so what's 4 more years here? 10, I think Gabby said 10, faintly, but I heard her a little bit. Then we decreased to 7%. So let's go ahead and graph these points. Do you think it's helpful to think of it that way? To graph, to put it on the table? Well, I think it's pretty helpful. So we have 4, 4.4, so 4, 4.4. And then we have the sharp increase after that, so 6 to 10, right? We went up to 10 here. And then 10 is 7, so 10 is 7 right here. And then, and so these are the points. And if you wanted to just, you don't know exactly what it did, but something like this, right? Now this was a hard era for us. We were having a lot of problems here.
problem?
And you had a lot of people out of work, a lot of homes, it was a housing bubble. And so really you need to thank your parents for helping you keeping it all together during that difficult period of time. But now we have another challenge, and all of y'all are doing a good job helping us with that, right? Yes. Wearing the mask, distancing and everything, being responsible.
Absolutely.
Good job. All right. I saw something on Facebook that says, let me get this straight. I can save the world by sitting at home on my couch and watching TV.
Yes, you can.
Yeah, that was pretty much it since March. But now we're back to work. Now we're essential workers, right? All of us are essential workers. Okay, let's go on to 13. Following describes incidents of mumps. Okay, again, talking about a real, now these may be contrived. Now, do you notice what happens to be on the x-axis here? Time, right? And over here, what happens to be on the x-axis? Time, right? You remember the song I did yesterday, right? What was in the song? Money's usually dependent and time independent, right? So that's the way these things just tend to work out. A lot of times it's money on the dependent axis, but could be, here we have rates of infection. So how do you want to do this one? You want to spend a couple minutes yourself working on this thing, and then we'll go over it? No? Yeah? Ben says yes. Yeah, spend a couple minutes working on that, then we'll come back to it, okay? Okay, for this one here, did you all set up a table for this one?
Yeah.
Like, did that work out pretty well? So let's just go ahead. Go ahead and tell me what you got in the table here, somebody. You start at 0, right?
Yeah, 5 point, or, yeah, 0, 1, 2, 12.
0, 1, 2, 12. Anything else? We should go up to 20 here somehow.
The last, because it's,
Okay, let's just fill out what we have here. So we know at 0 we stayed at about 1 case after 1 year, right? And then there was a spike to 5.5 cases here, right? Wait a second. No, two cases.
there's a spike, yeah, for, yeah, 5.5 is on number 1.
5.5 is 1,
It's on 3, I thought.
Yeah.
What it should be
That
on
on
3.
30.
Yeah.
so 3. So there should be 3 here, right? Like this?
No, not the 2, 3. No, but like erase the 2. Because it doesn't say anything about 2 years.
Oh, okay. So you're saying this should be 3 instead of 2. So 2 years later, so that's 3. Now is that good?
Yes.
There was a spike, so that was 1987, which is 3 years later, so now we're to 5.5, right? And then it says, over the next year, there was a sharp decline, so what's that going to be? 4, right? Sharp decline to 2 cases. Then from 88 to 89, that's going to be year 5, right? So we went to a small increase to 2.5, and then we had next we had this is followed by a gradual decline in 1999.
So that was 15.
So it'd be 15. That's a long period of time, right? 1.1, and then 20, we stayed, right?
Teachers and students, pardon the interruption. Teachers, just a quick reminder that tomorrow's our Fun Day exchange. Bring a $2 gift, bring it to the office, and have a little fun on Friday, fun Friday. I like that. All right, that's all I got. Enjoy your last period of the day, and go Wildcats.
Okay, thank you, Mr. Casas. So we go like this, right? So 1, 1, and then 3 is 5.5. And then 4 is 2. 5 is 2.5, so 5 goes to 2.5. And then 15 is 0.1. And then 20 is also 0.1. So things are going to look something like this, right? Isn't that odd that there would be that kind of a spike though in 1 year?
Yeah.
You don't know what it is. I don't know what happened there. Have any of you ever had the mumps?
Had what?
The mumps, that's what it's talking about. You ever had the mumps? You know what mumps is? It's a highly infectious disease. And my era, when I was a little kid, was before 1984. And it was a very common disease back then. So common that everybody got it. I got it. And basically you'd have glands that were swollen up. You'd have the mumps, and you'd be out of school for a week or so. And you'd get better. But it was not it wasn't seen as a dangerous disease. And it's this kind of disease that's not dangerous if everybody gets it when they're young, but it's harmful as you get older. And the reason is, especially for men, because it affects like reproductive things for men, especially when they get older. So if you have it when you're a kid and got over it, you're okay, but if you have it when you're older, like you guys now, that's when it becomes harmful. But they gradually eradicated, at least in our country, that disease, so people don't know what it is anymore, fortunately. I think there's a vaccine for it too. If you go to a country that has it, you can get a vaccine for it and you'll be protected against it. All right, questions on this one? No hay preguntas? No hay preguntas? Okay, let's go on. Now aviation, we have this thing right here. So again, we're looking for, you have correlation between a wingspan and length. And we're introduced to this thing right here where we're making what we call a scatter plot. And we're going to work more with scatter plots tomorrow. But how would you set this one up? I would do the same type of thing, right? So here you have it says X representing length. And so here's the lengths right here, right? So if we just go like 130, 148, 155, is that what it is? And then 178, and then 180, and finally 209. And then we can come over here and just write these things down. These numbers right here, 113, 108, 124, 147, 156, and finally 200. And now we can use this to kind of make a scatter plot. So you go here to 130, right about here, and go up to where? To 113. You just kind of look, and you have to kind of estimate. Here's 100. Here's like 120. So somewhere about halfway in between. So you come up to about here. Now, when you plot your own scatter plot, is yours going to look exactly like your neighbor's?
No,
No, it's not. Why not?
because we can see the lines.
Yeah, well, that's one thing. Limitations of, I wasn't even thinking of that. But even if you could see the lines, would you still look the same as your neighbor's?
Yeah.
No, it wouldn't. Why not? Part of it has to do with the interpretation, right? You have to estimate between these values here. And will estimates be the same for everybody? No, they won't be. Then you get 155, 124, so it's going to be almost like, well, that's 120. So it's going to be about right here, isn't it? And then 178, 147. So 178 is going to be about here. And 147 is going to be about here. And then 180, now 180 is really close to 178, right? So really it's the same place, but you go up to 156, so it's going to be, or close to the same place, 156 is going to be almost just right next to it, right? Right next to that one. Finally, you have 209 and 200, so something like this. So 200 will be about right here. So does yours look kind of like that?
Yeah.
Yeah, Addie should, yeah, it looks kind of like that. So we've done that. And so, but you did this back in Algebra 1 with Miss Tubbs, right? Everything, you remember that? Good. And now it says B, sketch a line of fit. What is a line of fit?
A line for where they're all going.
It's a line where they're all going, right? So you're trying to get a line, you're trying to build a linear function out of this. And why do you want to build a linear function out of this? To predict, which gets us to part C, right? Okay, very good, Connor, all right. So let's go ahead and draw the line. I'm going to access my tools up here. I go to line, and I press right here, and this allows me to kind of draw like a line. And is your line going to be the same as your neighbor's? No, not exactly, right? Because you're just sort of estimating where it is. So I can move this thing up. I can move it around a little bit. I can also tilt this thing with the tools I have a little bit, right? Does that line look like it's pretty good estimate there that I've drawn? Maybe a little higher, but maybe I can move it a little bit higher. That might be a little better, but again, if you do it manually, it's not a perfect correlation. Now, tomorrow, when we do linear regression, we're going to use our calculators. Actually have the calculators use a method to do that. So now we have this, and we've sketched the line of best fit. This says line of fit, and we don't know if it's a line of best fit yet, but so let's go. And tomorrow we might actually come back and do this with the calculator and see how much different it is. Anyway, use the line of fit to predict the wingspan of the airplane. So we have this of 220 feet. So how do we use this line to predict, as Connor says? Where do we go to look for prediction?
240.
So we go over here to 220, right? And then we come right up here to, so right here, and then we go over this way, right? So what do we get over here on the y-axis? What number is this going to be approximately?
210.
Yeah, maybe 210, 205. Let's go with 205. Now, we'll say 205 feet. Now, it so happens that in, I think, 7th period class, I think the way the line came there, we estimated 200 feet. But you can see how it would be easy to get off a little, right? But that's it. Tomorrow we may just find out exactly what it is when we get to that, according to what the calculator gives us. Okay, 15, we get to golf. The table shows the height in feet of a ball at various times in seconds. So how would we do this one here? Graph the data in the table. Well, we already have a table. So is this one going to be easier than the other ones we looked at on 13, 14? Yeah. So we have 0, 0. We have 0.5, 28. We have 1, 48. And then what's the next one? 1.560. And then we have 2, is it 64? And then we have 2.560. We have 348. And then we have 3.5 28. And then we have 4, 0, right? Now, do you notice any kind of symmetry in the sketch there? What kind of symmetry do we call that? See, we have what kind of symmetry? Yeah, reflective symmetry. Peyton, you said that? Yeah, Peyton, it's very good, Peyton. Okay, yes. We have reflective symmetry about the line x. That's actually it's t, right? T equals 2. So reflective symmetry, and then you can kind of see these numbers being the same, right? So that corresponds with that. Okay, next, what is the maximum height the ball reaches?
64 feet.
So 64 feet. At what on what interval is the golf ball's height increasing? I'm going to call this function h of t, because we have height feet, so I'll call that h of t. We have t h of t. So h of t is increasing on what interval? 0 to 2, right? And that's a good call, because some people will say 64, right? But you're looking at the x values. On what intervals is the ball's height decreasing? Well, h of t is decreasing on interval. I heard Jaden or somebody say it, 2 to 4, right? Is that right? Okay. Questions on this one? I like the symmetry here. You could kind of put dotted line in between those if you wanted to, but we'll just go on here. 16, we have the model A equals 0.25t plus 29 represents the median age of females, A of females in the United States as a function of time. I want to suggest rewriting this function here. Instead of calling it A, I'd rather call it A of t equals 0.25 t plus 29. Why would I put this A of t here? Why did I change that function a little bit, you think? What'd you say? Why did I do that?
So you don't get confused?
So you don't get confused. And what I'm doing here is I'm trying to do just a little bit more to make this notation a little bit more descriptive, right? So you see that, you'll see f and x in parentheses a lot. So that could be helpful. That would be like f, the function f is a function of x. Here you have A of t. Now it says predict the median age of females in 1995. So how would we do that? And we subtract out, how many years we got there, Gabby, did you say?
25.
25? Okay, 9. So 25, right? So 25, so we'll say A of 25 is equal to 0.25 times 25 plus 29. And what's that going to be now? There, you can get out your calculator if you have that. Because I'd have a hard time doing this level without a calculator.
Oh, it is not right.
What are you getting here?
35.
Yeah, 35,
30, 35.25? And that would be years, right? And then the next one, B, part B, would be, you're going to subtract out 1970. So how many years is this going to be? $45? Yeah. So here we have A of 45 is equal to 0.25 times 45 in this case, plus 29. And how many years is that, Gabby?
40.25.
40.25 years. So we have these answers here, and anything else, anything, other comments to make?
Nearest 10.
Pardon me?
Said the nearest 10.
To the nearest 10th? Okay, yeah, let's do that. To the nearest 10th, how do we do that? That's a good call. To the nearest 10th. Let's go ahead and make this right. That would be this, right? And this one here would be, very good. I like that attention to detail, Jaden. Good job. Okay, any other observations? That was a good one.